Hello everyone, we are going to start here the new topic, that is the properties of radical. So what is the radical here? Radical mean all the expression which involves radical. Radical mean the root, any type of the root, that is the square root, cube root, fifth root, seventh root, but that involves the root. So we will learn here how to convert the radical expression into exponential and exponential into radical. In the same way, we will learn about how to simplify these radical expression. But here in question number 1 of exercise 2.3, we are going to do its question 1, that is about write each radical expression in exponential form and each exponential expression into radical notation or form. Notation mean here that is the form. Write each radical expression in exponential notation. Mean radical form will be converted into exponential form and each exponential form will be converted into radical. So do not simplify. We will not simplify. We will just have to change the notation of this. So here in part 1 you will see that is the cube root of minus 64. This minus 64 is the radicand and this is called, as a whole this is called the radical, and 3 is the index of radical over here. So guys, here you will see that this form is the radical form because it involves a root. This is the cube root. So the radical form, we will convert this into exponential form. Exponential form means in which we represent any number, any expression in the form of the power, in the form of exponent. So here guys, you will see if there is the square root, we can write that as a power of 1 by 2. Here there is a cube root, so we can write this in the form of minus 64 is the radicand over here. So its index of radical is 3. So its exponent will be 1 by 3. So this is the exponential form of this given radical expression. Same like this, its part 2, that is its 3 by 5 is the exponent of 2. And you can see from here that always the index of radical is written in the denominator. Here we will see what is the denominator, that is 5. It means this 5 will be the denominator of the power, denominator of the exponent. So this radicand we will write as it is. This is given in the form of exponent, exponential form. We will convert this into radical form. So 2 I will write as it is, that is the radicand. For writing in the radical form, I will put here the sign of the radical. Always the denominator of the exponent is the index of radical. So here 5 is the denominator, that will be the index of radical, and 3 is the power of 2. So here the 2 will be having a power 3. So this is now the radical form of this exponential form. Next one is minus 7 raised to power 1 by 3. Again this is given in exponential notation. Exponential notation means this has minus 7 has a power 1 by 3. There is no radical. It means we will convert this into radical form. So in radical form, first of all I will write the radicand, that is minus 7 inside the root. The denominator will be the index of radical, that is 3, and 1 will be the power of 7, that is no need to write. Next one, y raised to power minus 2 by 3. That's again an exponential form. There is no radical. So we will convert this into radical form. Y is the index of radical. 3 will be the, y is the radicand. 3, denominator will be the index of radical here. And minus 2 is the power of y. So this is the radical form of this exponential form. So here in question 1, we converted the exponential notation into radical notation and radical notation into exponential notation. But we did not solve this. We didn't simplify these. Then we'll move towards the next question. Yes guys, here in question number 2, we'll have to pick out the true or the false statement from here. So in part 1, that is, the both sides are equal or not. 5 raised to power 1 by 5 equals to the square root of 5. Here the index of radical, you can see the denominator is 5. So the index of radicals should be here 5 and the radicand should be 5. Radicand is okay, but the index of radical is a 5. So there is no index of radical 5. So this is the false statement. Here on one side there is exponential form given, on the other side is the radical form given. So we'll just have to check whether they both are equal or not. 2 raised to power 2 by 3 and here the cube root of 4. The denominator is 3. So in the radical form here is the index of radical is 3, that is okay. 2 has a power 2. So here the 2 has a power 2, the 2 times will be 4. So this is 4. This is true statement. And the next one, 49 square root equals to square root of 7. We'll take the square root of 49, that is equals to 7, not square root of 7. So this will be false. Here there is x raised to power 27 and it has a cube root. So when we will solve this, we will simplify this. Can we get x cube from here? Because the index of radical is here 3. So it's the power of x is 3. But where is this x raised to power 27? So first we will simplify. See this s raised to power 27 and index of radical is 3. So it will be multiplied by 1 by 3. So it is cancelled. 3 9 times 27, x raised to power 9. Here it is x raised to power 3. It means this is false. Okay guys, after this we'll see its last question, question number 3. Here guys, in question 3 you can see that simplify the following radical expression. Simplify mean we are not just going to write this in the form of the exponent, we are going to simplify this. And you can see that this is the radical expression because it involves root over here and this has cube root over here. So how we are going to simplify this? First of all, we will have to write this in the form of the exponent minus 125 and here is the cube root. So its exponent will be 1 by 3. So here I am going to make the prime factors of 125, 525 times, 5 times and 5 1 times. So how many times 5 is here? It is 3 times. Minus is already here and its exponent is 1 by 3. So I am going to solve minus 5. When there are the two exponents, they both are multiplied. 3 multiply 1 by 3. Both 3 are cancelled. So minus 5 has a power 1. It means this is equals to minus 5. So this is the simplified form of this given radical expression. Yes guys, here in part 2 you can see that this is the 4th root of 32. So first of all we write this in the form of exponent. Exponential notation. 32 is the base and 4 is the index of radical. So here the exponent will be 1 by 4. Now in the next step we will make the factors of this 32. Two 8 times, 2 4 times, 2 2 times and 2 1 time. 1 2 3 4 5. 5 times 2 is here. But here in the denominator, this is 4. So we cannot cancel the 5 with 4. So we write as 2 power 4 into 2. Mean how many 2 are there? 5. I have written this as 4 2 I have combined here and 1 2 is here. Why I did do this? Because here the denominator of the power is 4 and this 4 will be cancelled by 4. But if I will write this in the form of 2 raised to power 5, that 5 will not be cancelled by this 4. 1 by 4, 2 raised. Now this 1 by 4 is the exponent of the whole expression. So this will be multiplied by both the powers with 4 and here is no power, so that will be 1. 4 into 1 by 4 multiply 2 into 1 into 1 by 4. Here I can simplify, this 4 is cancelled by 4. So this is 2 and 2 1 times 1 divided by 4. Again you can see this 2 I will write as it is and it cannot be solved further because we cannot make the factors of 2. So again I will write this in the form of the radical. How? Radicand is 2 and the denominator is 4. So here the index of radical will be 4. So this is the simplified form. Yes guys, here you can see that now the radicand having a fraction. So, but first of all we write this in the form of exponential form. The index of radical is 5, so its exponent will be 1 by 5. Now you can see from here that I cannot make the factors of 3, but I can make the factors of 32 that I have made previously, that is 2 raised to power 5. How many 2 is there? That is 5 times. So I can write this as 3 as it is and 2 raised to power 5. Its power is 1 by 5. Now you can see from here that this power 1 by 5, that is the exponent of both numerator and denominator. So here in the denominator you can write 3 raised to power 1 by 5. In the denominator you will write 2 raised to power 5 into 1 by 5. So this 5 is cancelled by 5. This is now 3 raised to power 1 by 5 and it's divided by 2. Now you can see that this is a simple value 2, but in the numerator this is 3 raised to power 1 by 5. So 3 raised to power 1 by 5, I cannot make the factors of this 3. So I will write this again in the radical form. 3 is the radicand and in the power the denominator is 5, so index of radical is 5 and here is the numerator is 1. There is no need to write that over 2. So our answer is here 5th root of 3 over 2. Okay, so you can see that in part 4 that is also very simple. First of all, you have to write this radical expression into the exponential notation, that is minus 8 by 27. Sorry, its exponential notation is index of radical is 3, so its exponent is 1 by 3. So here again, first of all I will make the factors of both numerator and denominator. 8 can be factorized, 27 can be factorized. So I will make the factors of 8, 2 4 times, 2 2 times and 2 1 times. Same like this I will make the factors of 27, 3 9 times, 3 3 times and 3 1 times. It means 8 is factorized as the third power of 2 minus I will write as it is. This minus is in the middle. So 2 how many times is there? 3 times. 27 is factorized as 3 how many times here? 3 times. So its exponent is 1 over 3. It means now this exponent 1 over 3 will be multiplied both the powers. This power 3 and this power 3. It will be multiplied by both. Minus I will write as it is. Numerator 2 raised to power 3 multiply 1 by 3. In the denominator 3 raised to power 3 multiply 1 by 3. Here you can see that this 3 is cancelled by 3. This is cancelled. So this is 2 by 3 and minus is already here, minus 2 by 3. So this is the simplified form of this given expression. So guys, here today we learnt about how to convert the exponential notation into the radical, and how the radical can be converted into exponential, and how we can simplify the radical expressions by converting them into the exponential notation. Thank you.